here's something very similar. Let's draw it here. You got, say the current comes in and splits up top and splits down here in the bottom, comes back together like that. What if the current, possibly my worst drawing ever, what if the current did this? I1 comes in like that, again, I2 up here, again, I3 down there, and again, I4 there. So now the two sides aren't the same. Let's say identical row and area, cross-sectional area, but not length. And you can tell by looking at it that the top one has a longer length than the bottom one. For this part is long, that part is short, clearly. All right. So we're just going to go through, and we're not going to calculate in detail. We're just going to ask relative who's bigger, top or bottom. So let's say relative delta V between, the thing we're looking relative is up here, this piece of wire, or down here, the bottom piece of wire, between the two junctions. Let's see, so what did making one side longer, what all did it change? Let's see, relative potential difference between here and here if you go to the top, here and here if you go to the bottom, where again this is A and B, and the answer is the same. Because that's the delta, that's the potential difference between those 2 points. We're not in electrostatics, but we're steady state current, which is kind of the same thing for potentials. So delta VAB, like we said before, would be the same for those two paths. Relative R, which one has the bigger R? So it's the top one, because resistance gets bigger when you make a wire longer. Or if you want to think back to the formula, rho L over A. So rho is the same, A is the same, but the L here is longer. So R2 is greater than R1, greater than R3. That. So R2 is bigger. Relative current. So you can pause the video and think about these if you want. So, relative I, which one is going to have a bigger current? Well, let's see, we know V equals IR, so I is delta V over R. We said delta V is the same, so the bigger current will be the one with the smaller resistance. Right? So it must be that I3 is bigger than I2. So that's interesting. Now when we look at it, we say, actually we get more current here in the shorter one. Right? It likes to, sometimes we say it takes the path of least resistance, but that's really not a right way to think about it. So it's going here because this has more of the current because the resistance is lower. The current that went up here took the path of most resistance. It's just more it goes the path of less resistance. So anyway, lower resistance, higher current, I3. And now let's do relative power, since I introduced it just a minute ago. Which one is going to have more power? But let's see, it's I times delta V. So we decided the current is bigger here than here, and actually the delta V's are the same. So it's going to be 3. P, the power dissipated in 3, is going to be bigger than the power dissipated in 2, because it's IV. And that means you're actually going to get more power down here, dissipated, than up here, which is a little weird, because this one's longer. You'd think the current goes through more wire and more chance to generate heat, but current's lower. You'll actually get more power down.